Laws of motion. Now, the next topic is uniform circular motion, right? Or dynamics of circular. So we have already done this uniform circular motion, right? And do you guys remember that when something is going in the circular motion, so towards the center there was this particular force which was acting. So what was that? Do you guys remember? Yes. Whenever the object is moving in a circular motion, so there was an acceleration towards the center, right?
Yes, sir.
Center of mass.
Center of mass. So that is sixth chapter, rotational dynamics, right? System of particles and rotational motion. So in that you will learn about the center of mass. But for the case of the laws of motion, we are assuming that all the objects are point particle, right? So
Okay, sir.
yeah. So the laws of motion is applicable only for the point particle. So we are assuming that all the objects are point particle, right?
Yes, sir.
There
Okay.
is a centripetal force.
Yes, centripetal force. Yeah, this was the answer that I was looking. So whenever the object is moving in the circular direction, so there is always a force which attracts towards the center, right? And in here also, and that force we call that as centripetal force, right? And do you guys remember what was the value of this centripetal force? Yes. So what was the value of the centripetal force? Or acceleration, do you guys remember what was the acceleration?
mv by r square.
Yeah, mv square by, right? This was the centripetal force. So
mv square.
partially correct. Good. So this was the centripetal force, right? So whenever the object is who's that? Okay, so whenever the object is moving in the circular path, so there will be always a force which will attract towards the center, right? And that is right, and that is called the centripetal force, right? So let's say that if you have a rope, and in the end you have attached some mass, and then you are rotating this mass with this rope, right? So this is the rope. So what is the thing that is providing this centripetal force?
Acceleration.
Yes.
Acceleration.
Acceleration. No, no. So I am asking that, okay, let's say you have a rope, right? So you have a rope, and then from this rope you are attaching some mass with it. And then you pick this rope in your hand, and then you just rotate this rope. So then this stone will rotate, right? So it will reach here.
So,
This is the stone. This is the stone. This is the stone. This is the stone, right? So we know that centripetal force is mv square by r, right? This is in this direction. This we know. So what is providing this centripetal force? This is the question that I'm asking.
Acceleration.
Acceleration is there, right? V square by r. Acceleration is there. So what is providing this acceleration? That is what I am asking.
Mass,
Yeah, mass is providing, but
velocity.
okay. So let's say that if you have a rope and you hang something through this rope. So what is the force which,
Gravity.
okay, so gravity is acting in this direction, right? In here this is acting in this direction, and in here this is acting in this direction. But I am asking that what is the force which is acting
The
against?
tension.
Tension, right? So now you guys look at these diagram and tell me what is acting towards the center.
The tension.
Tension.
Force.
Tension, right? Tension of the rope. So the tension of the rope is providing the centripetal acceleration. So this tension is equal to mv square by r. This is part clear.
Yes, sir.
So similarly, you have a planetary system, solar system. So we have a sun, right? This is a sun, and this is the Earth, which is rotating around the sun. So Earth is moving in the circular orbit, right? And when you learn gravitation part, so when you will do the gravitation part, then you will see that this is not exactly circular, but for now, let us assume that this is a circular path, and Earth is here, right? Okay. So now there's no rope between Earth and Sun, right? So
Yes, sir.
there is no tension between Earth and Sun. So now, but this is moving in circle, which means that something is providing a centripetal force. So what is that, guys? What is that for a Sun and Earth system?
Sir, you only said centripetal force.
Gravitational force.
Yes. What did you say, Rishita?
Sir, is it gravitational force?
Absolutely right. So gravitational force of acceleration. So this sun is pulling this earth towards its center, right? So gravitational force. Yes, okay, understood.
Yes, sir.
So this centripetal force, which is mv square by r, so this is equalized by gravitational force, right? Elham and Amna understood.
Yes, sir. Yes,
Good.
sir.
Good. So on the keeping these things in mind, right? Something provides the whatever force which is acting towards the center that provides the centripetal force, right? So for the case of rope and stone, tension provides the centripetal force, and for the case of sun and earth system, the gravity provides the centripetal force, right? So now we will understand about something more, but please note down this part, okay? And uniform circular motion I have already done, so that is why I'm not writing angular velocity, angular displacement, angular something. All those definition we have already done, right?
Yes, sir.
This is
Finished,
Sir,
sir.
finished.
any other examples where instead of only tension and gravitational force, something else is pulling it?
Yeah, so I will talk about that. So I will talk about that. So the next example is about that. Okay.
Yes, sir.
Okay, so who got disconnected? Amna got disconnected. Yes, whenever you guys have noted it down, so
Done, sir.
done. Alham and Akif and Amna,
Yes, sir.
you guys note it down.
Yes, sir.
Yes, sir.
Okay, so the next example is that let's say you are going in the car, right? And you take a turn in the car. Okay, so you are traveling in a car, and then you are taking a circular turn, right? So this is the turn. So let's say that this is the radius, right? And now you're moving in a circular, let's say half circular path. So then you will have some centripetal force, right?
Yes, sir.
Yes.
So as Rishita was asking that what is providing this centripetal force, right? What force is providing this centripetal force, right? So this car, right, which is moving, and it is right, so it is moving on this road, right? So something is pulling this car in this direction, right? So the tires are experiencing a frictional force in this direction, right?
Yes, sir.
So this friction is providing this centripetal force, right? If this road is frictionless, and then on that road you try to turn this car, so what will happen?
It'll start slipping.
It will slip and then it will go out of this road, right? So which means that this friction is very helpful in turning this car, right? In rotating this car. Because if the friction is not around, then this car will slip. Understood? So which means that this car is only moving in this direction. So in horizontal direction, does this car have any motion?
No, sir.
Which means that, right? So which means that this frictional force is balanced by the centripetal force, right? So this is friction, and this is equal to centripetal force, right? And this car is also experiencing some another force. What is that force?
Gravitational because it's
Yeah, yeah, absolutely. Because it has some mass, so this will always experience some gravitational force, right? And then because this is these surfaces are connected, so
Normal.
normal reaction, right? So let me write it as this is friction on an unbanked right, and this is example of slipping, right? Let me not write it, but so what are the forces which are there? So let us write the forces. So
so
force
what's that friction on an unbanked road?
this N.
No,
Oh,
no,
this
friction. Yeah.
unbanked. So this is a planar road, right? So the roads are, let me, so the roads are like this, right? These are the roads. Okay. The roads are not like this, tilted, right?
Oh,
So,
yeah. Okay, sir.
I have, okay, so the roads are not, if we bring the bigger, okay. Yeah, so the roads are not like that, tilted. The roads are smooth, right?
Yes, sir.
That is why unbanked. So, okay, so where was I? Yes. So what are the forces involved?
So one is
Gra-
gravitational.
Yeah, one is the gravitational force.
Other one
friction.
normal.
then as Rishada is saying friction and Akib is saying normal reaction. So we have normal reaction and the third one is the friction, right? And the important thing is that the friction friction is providing the centripetal. Understood, everyone?
Yes, sir.
Okay, so this car is moving with velocity, let's say v, right? So velocity is okay. Now, can you guys tell me that we have this free body diagram, right? So we have this diagram. Let me write it like this. This is N. This is mg. This is F, which is acting like centripetal force, right? So in the upward and downward direction, from the balance condition, equilibrium condition, what can we write?
N equals to
Sir,
mg.
N equal to h, right? Now, what would be friction? Remember, what kind of friction is this? Because this is not moving in this direction. In this direction, it is static. In the horizontal direction, it is static. So what kind of friction is there?
sorry, sir, I didn't understood what it is like.
Yeah. So we are not, this car is not moving in this direction or in this direction, right? This
Yes, sir.
car is moving in this direction, right? So which means that we don't have any motion in this direction, which means that this is static in this direction. So what kind of friction is there?
Sliding friction.
Static friction, sliding.
Static friction.
Oh, static. So what is static friction? For static friction, what is the frictional force? For static one.
Sir, the meaning of it, or
Yes. What is static friction? How do we write? So we have done lots of numericals, right? Okay, so you guys have forgot it. So this is mu s, right? And let me write it as mu s, right? So this is the maximum static friction and n. Remember now?
Sir, it is less than, right?
Yeah.
yes,
So
sir.
I am writing it as mu s, right? So this is obviously less than equal to mu s n, right? But I'm writing that this has the maximum friction that it can have, right? The maximum friction because
Okay, sir.
because after this the car will slide, right? This is the
Yes, sir.
limiting friction. So after this the car, so that's why I'm writing this as this one, right?
Yes, sir.
Okay. So we have this friction, but this friction is equal to what? So friction is equal to centripetal force, right? So this is mu L. Let me write it as so Fc is F. So this is what is a centripetal force?
mv square by r.
Mv square by R, right? So Mv square by R, right? And this is equal to mu L and right. Remember, this is the maximum value. So which means that this is the maximum velocity, right? So then this, what is this n? You already know. So let me calculate. So mu L and n, right? So let me plug this back. M cancels and we have V square. This is mu L and R and G. So this is the maximum speed, right? Because I'm using mu L. If I use mu S, so this would be V square would be less than equal to mu S RG, right? But if I use the maximum value, so this would be mu S. Understood, everyone?
Yes, sir.
Yes, sir.
So then V max would be how much? So this would be root of mu L RG. So this line tells us that this would be the maximum velocity with which we can turn this vehicle so that it doesn't have any motion in this direction. The frictional forces balance this, so it doesn't have any motion in this direction, which means that it cannot slip, right? So this value will tell us that whether the car or the vehicle will slip or not. So let's say that you are traveling with, let's say, you get Vmax equal to, let's say, 20 meter per second. And the V that you are traveling with is, let's say, 25 meter per second. So you are traveling with 25 meter per second and then you try to take the turn. So will you sleep or not?
We'll slip, sir.
It will slip, right? So this is the limiting velocity that it tells us. So this is the maximum velocity with which we can take the turn. Is this part clear, everyone?
Yes, sir.
Okay, so please note it down and then we'll do one question. There is no velocity in this direction. So whenever you guys want me to scroll down the screen, guys,
Finish, sir.
so this is right where mu L is the coefficient of limiting friction. R is the radius of the circular road. And G is gravity. So this V max is the maximum velocity with which vehicle can turn vehicle, right? Vehicle can turn without okay, so You guys please note it down and tell me whenever you have.
So just 1 minute, can you scroll up? I want to recheck
Yeah,
what group is correct.
which part?
Yes, sir, done. Thank you, sir.
Finished, sir.
Finished, everyone. Done.
Yes, sir.
Yes, sir, done.
Okay, so now we have, let us do one question, right? Then we can understand. So we have this question, right? This 4.10. So you guys please do this question and tell me the answer. Can I take the screenshot? Yeah, so please do this question. Remember what is given. So a a cyclist speeding at, so V is given. This is 18 kilometer per hour, right? This V is given, and radius is given. Radius is 3 meters, and mu S or mu L, right? Mu S is given 0.1, and then G unit. So with these, you calculate what is V max, and then you compare it with this actual velocity, and then tell me whether the cyclist will slip or not.
Okay, sir.
So a cyclist speeding at 18 km per hour on the level road takes a sharp circular turn of radius 3 meter without reducing the speed. The coefficient of static friction between the tires and the road is this. Will the cyclist slip while taking the turn? So you guys already know what is Vmax.
Sir, root of mu L R G.
Root of mu L R G, or we
Sir,
can
I'm
write it.
getting. Oh no, no,
Yes, you are getting what, Rishita?
nothing, sir. I thought I got the right answer, but I didn't convert the meter into kilometer.
Yeah. So this is kilometer per hour, which is 18 kilometer is 1000, hour is 36 cents. So you cancel this one, then 18 twos are, so this is 5 meter per second actually, right? And then what is the value that you get from here? Yes, guys, what is the value that you are getting? All the things
Sir,
are
I'm getting 3 kilometer.
3
Sorry,
kilometers,
3 meter per second.
3 meter per second, right? Akib, Elham, and Amna, what are you guys getting?
Doing, sir.
Remember, there is a root.
So I got root 3 V max.
Sir, it's root 3. I didn't root it.
Yes, sir, even I got 3.
Root 3. Good. And Amna, what about you? Oh, Amna has already written in the 173 meter per second. Oh, 1.7. So 1.73, which is root 3, right? Okay, so yeah, so this is 0.1, this is 3, and then this is 10. So this is root 3 meter per second, right? Which is 1.73 meter per second. So this is the maximum speed with which the cyclist can take a turn, right? But he is moving with this speed. So will he slip or will he be okay? Yes,
He'll slip, sir.
he will slip, right? So yeah, so he should reduce his speed, right? Understood, everyone?
Yes, sir.
Yes.
So what was the yeah, so 0.94? What are they? That is minus RG 0.9 square. What is that? So they have written in square of something. So the answer is that cyclist will sleep, right? So from here we got that cyclist, right? Good. Now, now what happens if the road is not level? So these kind of road are called the level, right? Unbanked road, or let me write it as level. So this is level. But in some cases, which may happen, that your road is banked, right? So you have this kind of, right? And the angle with the horizontal one is, let's say this is theta, right? And the car is, okay. So the car is moving. So where would be the normal reaction,
Perpendicular to the
Road.
right? So
slope.
perpendicular to this one. So this is the normal reaction, right? And the vertical part is this. So this would be your theta. Okay, understood?
Yes,
Yes,
sir.
sir.
And from here, the what is the other force?
Gravitational
MG.
force.
Gravity. So this is energy, right? And this tire is feeling some frictional
Then
force, right? And in this direction, you have the centripetal force, right? The so the car is moving. So in this direction, it is feeling the centripetal force, right?
Yes, sir.
So it will have. So this is this direction, right? This is friction. So if we draw the free body diagram of this one, so we have this is the normal reaction, okay, and this is the theta, and then this is your mg, okay, and then this is your friction, right? So this is making an angle. This is theta. This is 90 minus theta. Then this is theta. Okay, and in here you have the centripetal force. Okay, so this is a normal reaction, and it will have how many components?
three components.
Three. So you have this plane, right? You have this plane, and this is the vector. So how many components would be there in
Two.
rectangle? Two, right? So from theta part will have what? What will be the theta part?
Cos.
cos, right? So this would be how much? This is n, so this would be
N cos theta.
n cos theta. Absolutely right. And this would be what?
N sin theta.
N sin theta.
N sin theta. Absolutely right, guys. Good. Now, again, you see that this friction has, this is with some angle, with the horizontal. So it will have again two components. What would be this component?
F
This,
cos theta.
N sin theta and N cos.
so F cos theta. And then this one,
F sin theta.
F sin theta. Good. So we have a very, so this is the free body diagram of the bank. Is there any of the uh, term which is not clear to you guys? Any of the term?
Clear, sir.
Everything is clear,
No,
right?
sir.
Good. So now you guys can see that. You guys can see that the centripetal force is provided by how many things?
Sorry, sir?
So you have this centripetal force, right?
Yes,
Towards
sir.
the center, some force is acting. So this centripetal force is provided by how many things?
Three forces.
3.
So you have two, right? This one and this one. So friction and this normal reaction is providing the centripetal force, right?
Yes, sir.
Right. So, and let's say that in this question, right? So you are turning this whatever vehicle that you have. So the tires are applying some friction, right? So what will happen to the tires if it is applying some friction?
Smoke will come out.
No, yeah, so it will wear and tear, right? So
Yes, sir.
yeah, so it will be damaged a little, right? So not that much, but with friction, the layers would be get depleted, right?
Yes, sir.
So that is why you make what thick tires, right? So now, yeah, when we will solve, so when we will solve these equation, so in one condition we will assume that there is no friction between the tires, and that will help you in what? If there is no friction in tires, then only the centripetal force that will be provided by this normal reaction, right? There is no friction.
Yes, sir.
So
Yes, sir.
in that condition, what will happen that there will be no force on the tires, right? There will be no pressure on tires. So the tires will not tear and wear, right?
Yes, sir.
And then we'll also add this friction, and then we'll see that what happens, right? So remember, in the case of the banked road, we have two things which are providing the centripetal force, right? So when there is no friction, so that would be called the optimum condition, which reduces the wear and tear on tires, which reduces the pressure on tires. So we will learn about that condition, and then first let us learn about the total combined contribution, right? Okay. So now let us write the vertical equilibrium. So vertical equilibrium. So what would be that? What is balancing the total vertical forces? Yes. From here, what can you say? So you have, this is n cos theta And
N
then
cos theta will be equal to mg
you don't have anything else.
or f sin theta.
So both are combined, right? So n cos theta would be how much?
F sin theta into mg
Into
plus mg.
plus, right? These are adding up. Why they would be into, right? Understood?
Yes, sir.
Okay. And what is providing the centripetal force? So centripetal force is provided by what normal reaction, which is one component of normal reaction, and friction, right? So can you guys tell me that what is centripetal force in here? Let me draw the diagram. So we have this is what F cos theta, and then this is N what sine theta, and this is my centripetal force. So what would be the centripetal force, guys?
Sir, f cos theta plus n sin theta.
Good, absolutely right. So N sine theta. Okay, good. So this is the second equation, right? Everyone understood this part?
Yes, sir.
Okay, so now let us try to solve this equation and the ultimate. So in the level load, what did we calculate? What did we calculate?
V
The
max.
Yeah,
maximum velocity.
yeah, we calculated the maximum velocity with which we can move, right? Without slipping. So similarly, we will also calculate the same scenario. Okay, so let me write again those two equations. And we know that what is friction. So let me also write the third one. Friction is how much?
Sir, there is nothing about friction.
Hmm. Right. I am assuming that this is maximum. So that is why I'm writing this equal. Okay.
Okay, sir.
So I can also write this as L, but assume that mu L is mu S max. Right. So this is okay. This is equal. So I can write it as mu S, and okay, let me write it as. Okay, so these are the three conditions, right? So let us write the two equations. First equation was what? First was n cos theta is so n cos theta is f sine theta plus mg, right?
Yes, sir.
So mg is n cos theta minus f sine. This is first. And the second equation is Fc. Fc is equal to f cos theta plus n sine theta. Understood?
Yes, sir.
So what is the centripetal
Yes.
force? What is the centripetal force?
mv square by r.
mv square by r. So this is, let me write the capital. Okay, so this is f cos theta plus n sine theta. And let us write this as the second equation. This is the second equation. So we divide the second equation by first. So divide the second equation by first. So we have mv square by r divided by mg, and this is equal to f cos theta plus n sine theta divided by f, oh, n cos theta, n cos theta minus of f sine, right? So what is cancelling? This is cancelling,
M
right?
and M.
So m and m is cancelling, and b square by rg. This is what we are getting, right? And can I write f? So I know the value of f. So I can write it as mu l, right? And n cos theta plus n sine theta divided by, remember, whenever I'm writing mu l, which means that this is max, right? So this is n cos theta minus mu l and n sine theta. So what is common in this equation, these two terms, numerator and denominator? What is
U L N sine theta.
only n is common, right?
Yes, sir.
So we take n common, so this is mu l cos theta plus sine theta divided by, let's take, I also take n common from here. So this is cos theta minus mu l sine. N gets cancelled out, and we have r, and then g. This is g. Now we can also simplify this further. So what we can do is that in here you have this cos theta, right? So what I do is that I divide each terms by cos theta. So I divide this by cos theta, right? And I divide this by cos theta. And again I divide this by cos theta and divide it by cos theta. Okay, so then what you will get? You will get b square by
U
r.
L plus
Yeah,
tan theta.
absolutely right. So this is mu l plus tan theta, and then 1 minus mu l tan. Okay. Then if you
Yes.
take this RG on the other side, remember this is max. I am using L, so this is max, right? So B square is RG, and mu L plus tan theta, and 1 minus mu L tan. And if I calculate B, so this is B max. This is root of RG and mu L. So in the literature, it is given like mu s. So let me write it as. Okay, so the this is the maximum speed with which we can turn in the bank road without slipping. Understood?
Yes, sir.
Okay. Any doubt in this part? Do you guys have any doubt?
No, sir.
Okay, then please note it down. Please note it down from there, from here, right? Oh, from here. So this is bank. Circular motion in bank. So if you can remember this diagram, then all the parts are right. So you have to just remember this one. Whenever you guys need me to scroll down the screen, guys, please tell.
Yes, sir. Finish.
Oh, finished. Okay, so
Finish, sir.
finished. Whenever you guys need me to scroll down, please tell.
So can you scroll down?
Yes, done.
Yes, sir.
Answer.
Done. Yes, everyone noted?
Yes, sir. Finish.
So V max is the maximum speed with which with which the vehicle can turn without right. But we can also have one condition where this these tires, right? The tires of the vehicle doesn't experience the wear and tear, doesn't experience the friction, right? So in that case, what part is zero?
F.
Friction is zero, right? So for that, let's say V is equal to root of Rg. This is Rg and then mu s plus tan theta and then 1 minus mu s tan. So now I am saying that to reduce the wear and tear of the tires, right? So we don't want the damage on the tires, right? So then in this equation, in this relation, which part would be zero if friction is zero? What is providing the friction in this relation?
Sorry, sir.
So what part is providing the friction in this relation?
The gravitational force.
This part is mu s. This is related with the friction, right?
Yes, sir.
So to have the friction to be zero, so for frictionless surface, right? Mu s is zero, right?
Yes, sir.
So when so when we don't want wear and tear on the tire and without slipping, right? Then that velocity is called, so then mu s is zero and v is called the optimum velocity. Okay, so let us try to calculate v optimum. So this would be simply root of Rg and then 0 plus tan theta and 1 minus 0 into tan. This would be simply Rg tan theta. So your V optimum this would be root Rg tan. Is this clear?
Yes, sir.
Okay, so please note it down and then please note it down. And then we will do one question. So remember, whenever they want us to calculate the optimum velocity, so we use this lower one. And whenever they want us to calculate the maximum velocity with which we can turn the vehicle, that then we use the upper one.
Finished, sir.
Finished. Elam, Rishita, Amna, what about you guys?
Yes, sir.
Done. Okay. Now, yes, Elham and Amna, what about you guys?
Yes, sir.
So now let us again this problem, right? So we have this question, and don't look at the answers. Okay, so you have a circular racetrack of radius 300 meters and is banked at an angle of 15 degrees, right? Oh, this one. So let's change the question to, because we don't know the value of 15. So you have a racetrack, radius is 300 meters. Okay. And let us take angle to be 45 degrees, right? So let us take 30 degrees. 30 degrees. Okay. And if the coefficient of friction between the wheels of race car and road is mu s is 0.2, what is the optimum speed of the race car to avoid wear and tear on its tires? Right. So the optimum speed. First is V optimum, right? And then second one is without slipping. So maximum without slip. So you guys calculate and tell me. There is no other information. Oh. So you guys please calculate and tell me what are the values that you guys are.
Okay, sir.
Rishita, Aki, Elham, and
So I'm getting 10 into for V optimum.
yeah, V
10.
optimum is 10 meter per second.
Yes, sir. 10 into root of 10.
Oh, 10 root 10.
No, root of 10 into root 3. Like the root 3 is under a root. So does it?
Oh, you have root of root. Root 10
Yes.
and then root 3.
Yes, sir.
What is G? G is 10.
No. 10 into root, this thing, the one which you just wrote.
Yeah, 10 into
Root of 10, root of 3.
root of 10 and into root of 3.
Yes, sir.
So root of 10 and then root of 3. Like this.
No, so the thing which you wrote before, that multiplied by only 10.
Oh, so the thing that I wrote before was this 10 and then 10.
Yes, sir. I don't know if it's right.
Oh, so this is a very complicated one. And Akib, Elham, and Amna, what are you guys getting?
Getting, sir.
I got 28.
28, what? Which one? Yes, optimum or max one? Which one?
Optimum.
Optimum. So 28. Okay, so this is 1.73 and then 10, so 17.3. So 17 root 17.3 is how much? Seventeen point three two is 4.16 into 10. How to get a simple one? This is a very simple one. Remember, theta is 30 degrees. I have changed the question.
Sir, I got V optimum as 10 root 30.
10 root 30. Okay. Amna, what about your answer? So we have three distinct answers, right? Three totally different answers. Yes, Amna, what did you get?
Sir, you changed the angle?
Yeah, I have changed the angle because 15, 10, 15, we don't know, right?
Yes, sir.
So that is why I have changed the question. So did you
So
take,
I put in different some other value.
oh, that is
I
why
also
you,
did a calculation mistake. I'll do it again.
yeah. Please do that. And Amna, what are you getting? Or you are stuck at some point. So we know that V optimum is how much? That is root of Rg tan theta. This is the optimum velocity, right? Speed. So to reduce the wear and tear of the tire, right? So this is root of R is 300, G is 10, and then tan 30. So we have, okay, so this from this 110 is outside, and then we have this 30 and then tan 30, 1 by root, right? Okay, so that's why we have this complicated theta, right? So then we multiply this by root 3 and then 3, so this is 10 and then, right? And when we solve this, guys, so we'll get 41 point, how much? 617. So meter per second. Understood, everyone?
Yes, sir.
Okay, so now you guys calculate this Vmax, right? And that is also a complicated. So please calculate because this is a very important question. This uh, this is very important, and they may ask this question.
So can you show how you did the multiplication again of 10 to 12?
Yeah, 41.61.
Yes, sir.
Okay, so this root 3 is this is 10 and then 10 root. So this is 10 and then 10 into root 3 is 1.7, right? So then this is 10 into 17.32. And I, from mobile, I calculated the root of 17, which was something like 4 point something. So this was 4.16.
So can we leave it at 10 root 17.32?
Yeah, we can also, because we don't know the value, so we can leave it at that. Right.
Sir, how we got 10 outside?
10 outside. Okay, so in here, good. So that is what I like. Whenever you have some confusion, you are. So this is 300 into 10 and into 10. Right. So I can write this as 3 into 10 into 10 into 10 and then tan 30. So what is the pair that I have got? So this is the pair, right?
Yes, sir.
So then I can take 10 outside and then I'll have 30 and then tan 30 is what, right? So this is how I did it. Understood?
Yes, sir.
Okay, so you guys please calculate this Vmax.
It's 6 root 10 for Vmax.
6 root 10. Okay. And Akib, Ilham, Amna, what are you guys getting? So now this chapter has ended, right? This was the last topic. And the next topic is some common forces. So solving problems in mechanics. This we have already done, right? So then oh, this is complete. And then I will start work energy and power. So before I start that, do you guys remember the dot product?
Yes, sir.
So I will quickly revise that and then I'll start, right? Then I'll start the next chapter. You guys first calculate this and then
And I'm getting 10 root 6.
10 roots. So that is the opposite, right? Okay, Ilham and Amna, you guys please calculate and then
Sir, even I got 6 root 10.
6 root 10. So we have some majority here, right? Akib, so do you want to
Yes, sir.
change? Do you want to change your answer because we have a majority here?
No, sir.
No, oh, good, good. So yeah, you have to be confident in your answer. Good. 6 root 10, but everyone else is getting. Okay, so let us try to calculate, right? Let's see if I remember the formula. This is RG and then mu L plus tan theta and then 1 minus mu S, let me write, and then tan. This is the formula, right, guys? So 300
Sir,
into, yes,
instead can't we just use a root of MSRG?
mu S RG, but this is a banked road, right? Remember, this is a banked road.
Okay, sir.
This is not unbanked, right?
Yes, sir.
So what was this? This is 0.2 plus 1 by root 3. And then this is 1 minus 0.2 by. So we take the LCM, right? So this will become 3000 and this is 1.70, or let me write it as 0.2 root 3 plus 1 divided by root 3 minus and cancelling out the denominator. So 3000 and this is 1.73. So how much is this is 6 and this is 14 and then this is 3. So 3.46. 3.46.
I chose the other one. The Vmax equals to ULRG.
ULRG. Why ULRG? This is a bank road, right, guys?
Okay.
So this is a bank
Sir,
road,
even
right?
I did that.
Oh, so everyone, okay, okay. Whenever you see the angle, right? So what did we learn? That we have two. So for sleeping condition, right? So this was the optimum condition, and Vmax was this, with which the vehicle can turn without slipping. So without slipping condition is this, right? Vmax,
Yes, sir.
because the road is banked, right? And when the road was level road, then we can apply this one. So then we can apply this one. Okay.
Yes, sir.
Yes, sir.
Okay. So I Okay, so then we simplify this, right? So this is uh, 1 minus 1.73 minus 0.2, right? So this is 3000 into 3, so 4.46 divided by, this is 3, this is 5, 1.53. So how much is that? Let me use the calculator. This is 1000 into 4.1000 divided 1.5. So 8745. Oh, this is a very. So we are getting a root of 8745.09. And when we take the root, so what we'll get? So 93.51 meter per second. So this is the maximum speed with which we can turn our vehicle, right? So you see that optimum was how much? Optimum is 41, right? Optimum is
Yes, sir.
41 and maximum speed is 93.5. But this speed will damage your tire, right? Not that much, but it will damage your tire. So your tire will feel wear and tear, right? Some friction. So when you want to turn your vehicle without wearing and tearing, then you use this speed. But if you want to have more speed, right, then you can go up to this speed without okay. So
Yes,
please,
sir.
yeah, please note down this part, and if you have any doubts, so please ask. Uh, So what was tan of 15? They are not. Whenever you guys have noted it down, please tell. Who got disconnected?
Finish, sir.
Finished. Who
Done,
got
sir.
Ilham?
Yes, sir.
Okay, good. So this completes your chapter, right? So which chapter was difficult? The motion in plane, straight line, or this one? Which one?
Motion in plane.
Motion in plane. So motion in plane had what? Projectile motion, then relative motion, then circular motion. These three topics were there, right? So
Yes, sir.
yeah. Okay, so what you do is that you revise that chapter, and whenever you find any doubt, Rishika, then please ask. Okay.
Yes, sir.
Okay, so from tomorrow, I will start this. So from tomorrow, I will start this work energy power. So
Sir, can you take some extra classes for work and energy?
work energy. Okay, so work energy and hmm. So when is your exam, Amna? Yes.
1 minute.
Yeah, please check your date and first is what?
Twenty-six, sir.
26th. Okay, so yeah, so can you guys? So I can only take the classes on Saturday and Sunday, and Monday I have class. Okay, so tomorrow, yeah, so tomorrow you guys come at 5 o'clock, right? And then we can take the extra class of this work energy and power.
Sir,
So we,
Indian time, eh?
yeah, 5 p.m., which is 2, what, 2:30, right? So 2:30 KSA.
Yes, sir.
Okay. So you guys be there at 2:30 KSA, and then I will take the extra class, right? So we'll quickly complete this work energy and power so that Amna, yeah, so Amna syllabus is complete. Because in her exam, they will ask this work energy and power, right? And in Akib, your school, which chapter they will ask?
Sir, full book.
Oh, yeah, you have already told. Full book. So what is this full book? Okay, and Rishita, what about? Oh, so in your school only 4 chapter, laws of motion, right?
Laws of motion, sir.
Good. So Rishita, you start revising, right? And you guys also. And tomorrow, please be here at 2:30 KSA, right? So I'll start
Yes,
work.
sir.
Yeah, I'll start work energy there, and after 1 hour, then we'll take another class at 7:30, right? So in this way, we can complete this chapter. Okay.
Yes, sir.
Okay. So you guys have this class assessment, right? And it's yeah. So please log into your Learnivio account and check whether you are getting the active test or not.
Sir,
Yes.
I can't join at 7 o'clock
So
because
you
I'm having JE class at 6:30.
6:30. No, no, no. So you have a regular class at this time, right? 7:30 KSA.
No, 6:30 here,
6:30. So you have a
regular
class.
classes.
You have a class tomorrow with me, right?
Yes, sir.
So at that timing, I'm saying the
Ah, okay, sir.
yeah, yeah. So at that time, and the extra class is at 2:30 KSA, which is 5 p.m. IST, right?
Yes, sir.
So yeah, did you guys find the active test?
Sir, it is relative velocity in 2D.
Yeah, yeah. So that we have done, right? The rain umbrella problem. Rain umbrella,
Yes.
yeah, or whatever. Relative velocity is what? PA minus P. So relative velocity with respect to V, right? PAB is PA minus V. So we did some problems based on relative velocity.
But sir, it is motion in plane, right?
Yeah, yeah, yeah. So in motion in plane, we did